In lesson 11.6, what we're going to do is we're adding and subtracting rational expressions. Now, if you remember, what we've done in 11.4 is we simplified rational expressions. That just meant we simplified fractions. Those fractions had variables in them. So it could be like 2x over 6x. We simplified that fraction. Then in lesson 11.5, we multiplied and divided rational expressions. That meant I was multiplying and dividing fractions with variables. Okay, I would simplify them and then multiply them. Now today we're going to add and subtract rational expressions, which just means add and subtract fractions with variables. Okay? Anytime you want to add or subtract a fraction, what do you have to have? Rashid, what do you have to have when you add or subtract fractions? Somebody help him out. What do you have to have when you add or subtract fractions? Not like terms. This is going back to elementary. Common denominator. So if I had like 2 over 4 plus 6 over 10, I cannot add those. I can't say, 8 over 14. It doesn't work like that. I have to have a common denominator. And what is a good common denominator for 4 and 10? Let's do the smallest. 20. So I would say, all right, let's multiply this by 5. Whatever I do to the bottom, I've got to do to the top. Multiply this by 2. Whatever I do to the bottom, I got to do to the top. And then I have 10 over 20 plus 12 over 20. Now, when I add these fractions together, I would get 22 over what? 20. I do not add those together and get 40. You never, ever, ever want to change your common denominator, okay? That's exactly what we're going to be doing today. Now, what happens, though, if I've got something like this? Okay, in order to add or subtract these fractions, I have to have a common denominator. And when you're working with numbers and variables, you've got to have the exact same number and the exact same amount of variables. Okay, so let's work on our numbers first. 6 and 18. What's a good common denominator for 6 and 18? 18. Now watch this. It can be really simple if you just listen to this carefully about your variables. We have x and I have x squared. Okay? I have to have the exact same amount of x's. So the easiest thing I can tell you to do is look for the largest exponent, which is what? X squared. That's always going to be the amount of x's in your common denominator. Always. Never anything different. Okay, so if 18x squared is my common denominator, what do I need to multiply by 6x to make it 18x squared? 3 and x. Whatever I do to the bottom, I got to do to the top. Now, do I need to multiply anything by 18x squared to make it 18x squared? Nope. So I would now say I have 6x plus 7. Because I just multiplied those. And then can I add 6x and 7 and get 13x? Nope, because they're not like terms, so this would be my final answer. So that's exactly what we're doing today. Okay? In example 1, they want us to add or subtract. Look what they have given us already. Common denominators. So I don't really even have to do any work to get a common denominator. They've given it to me. So, anytime we have a common denominator, remember, it stays exactly what it is. All right? I'm never going to say, that's going to be 2y plus 10. Now, I just want to add my numerator. What's 3y plus 4? 3y plus 4. Is there anything I can do to simplify that farther? Nope, this is my final answer. Okay, now let's look at the bottom. I have a subtraction problem. Anytime you have a subtraction problem, okay, is everybody listening? What you want to do is you need to change the signs of everything after the subtraction sign. Everything in the numerator only. We will not do anything to our common denominator. So what I'm going to do is I'm going to make this x a what? Negative. And what am I going to make the 4? Negative. Once I do that, I can just change it to a regular old addition problem like we did in the last one. You have to change the signs of the numerator after the subtraction sign. What's my common denominator here? X plus 2. So it stays x plus 2. Now I just want to add like terms. First of all, does negative x have any like terms? Nope, so I'll leave him just like he is. Does 4 have any like terms? Negative 4. What's 4 minus 4? 0. So, I don't even need to write that. Can I cancel anything out now? Nope, because this x plus 2 right here is off limits. Remember, it's joined by a plus sign. So this is my final answer. All right, now I'm going to give you one of these to do on your own. I want you to do all right, I want you to do this one on your own. All right, somebody tell me, do you have a common denominator? Yes. So I leave my common denominator, which is 10y. And what do I need to do to my numerator? Change the signs. So what is it going to become now? I have a plus sign, and then it's going to be negative 5y and positive 2. So let's add like terms. What are my like terms, Dalton?
7y negative 5.
Which gives me 2y. And then what else am I going to do? Plus 2. Goes on the end. Now, watch this. This is where yesterday and the day before's lesson comes in handy. What can you do now? Take out a GCF. Because 2y plus 2 is off limits. It's got a plus sign that joins the two of them. So I can't just say, oh, y and y, 2 and 1/5. Doesn't work like that. Okay? But what I can do is I can take out a GCF. What's the GCF of 2y plus 2? 2. I'm left with y plus 1 over 10y. Now what can I simplify? 2 and 10. 2 goes into 2 one time. 2 goes into 10 5 times. So my final answer is going to be y plus 1 over 5y. You have to simplify everything down as far as you possibly can. Simplify everything down as far as you possibly can. Okay? All right, example 2. Now, look at our denominators. Is it a common denominator? 2x squared, 2x squared, negative 7x, negative 7x, positive 5, positive 5. So is it a common denominator? Sure is. So all I want to do now is I want to keep my common denominator. So, all right, 2x squared minus 7x plus 5. And I just want to add my numerators. But what do you see? What type of problem is this? Subtraction. So, Abby, what am I going to do? Very good. Change to addition. Then, perfect. Change the signs. Negative 3, positive 3x. Now we just want to add like terms. Now, watch this really quick. Standard form says my x needs to be first. So let's add negative x plus 3x. What's that number in front of negative x? So what's negative 1 plus 3? Positive 2x. Now let's add our constants. 1 plus -3 is -2. Am I finished? No. Let's section off what's off limits, which is everything, basically. Once everything's off limits, let's ask ourselves, can I take out a GCF? Yep. What's the GCF of 2x minus 2? 2. So I'm left with x minus 1. What can I do to my denominator? AC factoring. 2 times 5 is 10. List the factors of 10. Which ones add to give me 7? 2 and 5. So I know with AC factoring, that means I'm going to do 2x squared. What are the signs going to be in front of 2 and 5? Both negative. Minus 2x, minus 5x, plus 5. Factor by grouping. What do I take out of the first parentheses? 2x, and I'm left with x minus 1. What do I take out of the second parentheses? What kind of 5? -5. Perfect. And I'm left with x minus 1. So my new denominator is 2x minus 5 and x minus 1. All right. What can I cancel out now? The x minus 1s. They're identical. So my final answer is 2 over 2x minus 5. Can I cancel out those 2's right there? Nope, because 2x minus 5 is a pair, and it is off limits. We cannot do anything to it. All right, let me give you one like this to do on your own. All right, take a few minutes and do this one on your own. All right, somebody tell me what you did first. You kept the common denominator. Perfect. I look and I see I have a common denominator. Then what did you do? Okay, we just combined like terms. We left our x just like it is because it doesn't have any like terms. Then I added 5 plus -20, which is -15. Is this my final answer? Am I done? No, because what do I need to do? Just normal factoring. Can I do anything to x minus 15? So let's factor the denominator. List the factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now, I picked this one on purpose because there are 2 sets of factors that will give you 13. You get them different ways because I could do 15 minus 2 and get 13, or I can do 10 plus 3 and get 13. So how do you know which factors to choose, Morgan? Exactly, right here. This is a -30, so that means which ones subtract to give me 13. So which ones do I know I choose? 2 and 15. So I write x and 2, x and 15. Now what number gets what sign? 15 gets a negative, 2 gets a positive because it's a -13, so that sign goes to the biggest number. And now what can I cancel out? X minus 15. Now when everything cancels out up top, what am I left with? A 1. It does not just go away, and your answer is not just x plus 2. It's 1 over x plus 2. Okay? Last example here. They want us to add and subtract when I do not have like denominators. So we've already kind of gone over this at the very beginning, and we've got to find a common denominator. we got to find a common denominator. So I look at 3x squared and 6x, and I ask myself, what would be a good common denominator? 6 and x squared. Perfect. Now, how did you figure out to use x squared? I look for the biggest exponent, and whatever that is going to be my common denominator. So it's going to be x squared. So what do I need to multiply by 3x squared to make it 6x squared? 2. Do I need to multiply by an x?
No.
Nope, just 2. Whatever I do to the bottom, I have to do to the top. What do I need to multiply by 6x to make it 6x squared? X. Whatever I do to the bottom, I got to do to the top. So now I have 2 times 5, which is 10, plus 7 times x, which is 7x. Can I combine these together? Nope. Can I take out a GCF or factor anything? Nope. So this is my final answer. All right. Now, last but not least, this one confuses people if you don't pay attention. So I'm going to give you an example of a regular fraction, and then we're going to apply it to one that has variables in it. Okay? Watch this. What happens if I had 2 over 5 times 7 over 6? Okay? I don't have a common denominator, right? And typically when I need a common denominator, a lot of times, like if I were to have 2 plus 6 plus, that's supposed to be a plus sign, 3 over 12, I could say, oh, 12 would be a good common denominator, so I just multiply this one by 2, and I don't touch this one, right? But in one like we have right above it, 5 and 6, is there anything that I can do to multiply by 5 to make it a 6? No. Is there anything I can multiply by 6 to make it a 5? No. So I have to come up with a totally separate common denominator. The easiest way to do that is to multiply them by each other. So I multiply 5 by 6 and 6 by 5. Whatever I do to the bottom, I got to do to the top. Now, we only ever get a common denominator by multiplying. We will never add, we will never subtract, and we will never divide. You only multiply. So, sometimes the easiest way is just multiplying it by whatever you have on the other fraction. Let's look at this problem right here, this example that I've given you. Can I just say, oh, perfect, just add plus 1 here? No, you never ever get a common denominator by adding, subtracting, or dividing. So, is there anything I can do to x plus 1 to make it x? No. Okay, let's multiply by 1. Is that going to make it an x by itself? Nope, it's not going to. So, let's ask ourselves this. What can I do to x to make it x plus 1?
Another x.
Okay, let's say if I did another x, what would I get? X squared. Does that match up? No.
You know what I meant.
Okay. So what if we multiplied by 1? What's 1 times x? 1x. Does that match up? Nope. So guess what? There is absolutely nothing you can do. So anytime that happens, this is all you do, multiplying by each other. So this side gets multiplied by x. Whatever I do to the bottom, I got to do to the top. And this side gets multiplied by what? X plus 1. Okay. Now, my new common denominator is x times x plus 1. I don't need to distribute. I don't need to multiply it out. I can leave it just like it is. What type of a problem do I have? Subtraction. So what do I need to do to the numerator on this side? Change the sign, so I make this a negative x and a positive 1, and it becomes an addition problem. So let's start multiplying our numerators. What's x times 2x squared? Cubed. Very good. Now, how am I going to multiply these two terms together? What method am I going to use? I could do distributive, but what's the name for it that we use when I have four terms? FOIL. So, first, negative x times x is negative 1x squared. Outer, negative x times 1 is negative 1x. Inner, 1 times x is 1x. And last, 1 times 1 is 1. Do you see anything in our numerator that we can combine like terms? Negative 1x and 1x. Well, what happens when we combine those? Cancel out or give me 0, so I don't even have to worry about it. So now I just write 2x cubed minus 1x squared plus 1 over x times x plus 1. That's the answer. Okay? Now let me give you one of these to do on your own. Okay? If I gave you 3 over x plus 2 plus 5 over x. All right, I want you to take a few minutes and do this one on your own. All right. What should my common denominator be? Perfect. X times x plus 2. So I'd multiply this, the first fraction by x, and the second fraction by x plus 2. Okay, so my new numerator would be 3x plus what? 5x plus 10. Perfect, 5x plus 10. That 5 has to be distributed to both things. Now, do I have common or like terms that I can combine? 3x and 5x gives me 8x plus 10 over x times x plus 2. And there's your final answer. Is the 8x, what does the 8x have beside it? They're together. You cannot break it up. Remember, it's off limits. So you can't cancel out the x's. Now you could factor out a GCF if you wanted to, but when you factor it out, it's not going to do anything. So save your time and energy.
How do you know if you can do it right, if you should do it or not?
If you know, what is my GCF of 8x and 10? 2. So if I pulled a 2 out, would there even be anything for a 2 to cancel out with down there?
Yeah.
That's a pair, so I can't cancel anything out. The only thing it would have to cancel out with is this x, and I know I can't. So that's kind of why I know yes to factor it out or no to not. Okay?